Welcome to this Kistler webinar. It will focus mainly on the influences of road properties on WIM measurements, as well as the structural road analysis as a service. I'm Fabian Koke, the Junior Product Manager here in the SBF Road and Traffic and responsible for the SRA service and WIM product. Today's agenda. We will focus on the influencing factors on WIM measurements, elaborate a bit on the problems on how to measure and analyze them, the state-of-the-art technologies to measure road properties, as well as Kistler's approach to classify and simulate effects of road properties. I will conclude this with the success stories. So, influencing factors on WIM measurements. Basically, there are four known values which influence WIM measurements. The sensor's accuracy, the road properties, the vehicle dynamics, and the environment. While the sensor accuracy has widely improved over the last few years, vehicle dynamics and the environment are harder to measure and to compensate. All effects must be reduced as far as possible to reach high accuracy and performance of the WIM site. Kistler is able to measure the road properties with more than 20 years of experience in the WIM technology. Now, the focus of this webinar is to make you familiar with the influences of road properties and how to minimize them. Influences on WIM measurements. What are road properties? Basically, they consist of the structure and the surface of the road. It's not that the thickness or the material of the pavement itself is of a relevant value, more so the elastic modulus of the structural properties of the road. For WIM, a higher elastic modulus is desirable, but if you want to measure elastic modulus, you have to consider temperature since it's highly dependent. So what about the second factor of road properties? It's the surface. The quality of the surface is influenced by the rutting, cracks, potholes, and the profile of the surface. These errors are developing over time, as you can see in the picture on the right-hand side. So what happens first is some water gets in the lower part of the pavement in some other layers, such as the sub-base layer. And in the winter, this water is freezing and it will create some cracks in the pavement. And ultimately it will result in a hole. If you now apply some stress to it, for example, if a vehicle is driving over it, it will break in. The worse surface is adding to vehicle dynamics, which influence WIM accuracy negatively. Rutting has also an effect on the WIM sensor directly. So, why is the road geometry playing a role at all? First, parameters which add vehicle dynamics have to be minimized as far as possible. That is the driving behavior. For example, acceleration and deceleration / braking. What are possible causes for this kind of behavior? Most likely it's traffic obstacles such as traffic lights, toll stations, tight curvature, an interchange, slope, or construction work. But it's also about the road geometry directly. For example, if you have curves or a strong inclination. Let's come to Kistler's solution for this problem. It's a structural road analysis. With the structural road analysis, Kistler offers its customers to analyze and understand influences of road properties. This innovative approach is based on scientific research and is not comparable to anything what the market offers today. So what that means is that Kistler provided this service just for WIM measurements. What are the customer benefits of the service? To achieve maximum accuracy and ensure highest possible lifetime, to offer clarity to the customer about the quality of your asphalt or concrete pavement, reduced financial risk as well as reduced technical risk to avoid early fails of equipment in the road. Why is our approach so innovative compared to other established standards? So let's compare them directly. The established standards are outdated and not adjusted to the latest scientific developments. They are based on single-layer road models, and the measurements of structural road properties are averaged along the length of the measured road section, which means that exactly at the point where you want to place the WIM sensor, the road properties are not exactly known. Road measurements are usually conducted at the weight of 5 tons. If the weight is increased and a correction is applied afterwards, the mathematically calculated deflection will be incorrect due to a non-linear behavior of the road. Also, it is a big problem that these standards are not exactly temperature independent, and there is no correction for that standardized yet. And measurements are only taken in the middle of the road. So what do we do differently here at Kistler? We use a standard which reflects that the pavement is a highly complex structure, which means that we use a multi-layer road model to understand the road behavior. We take each single data point into account. Every data point must meet the minimal requirements. We do road measurements independently of weight, while ensuring that the minimal deflection of 0.2 mm is achieved. And we measure where it counts. That means that the left and the right wheel paths are differentiated. So, what's the process of this service? The first step is an assessment of side and road geometry. This can be done remotely. The second step is an IRI measurement according to our own measurement specifications. The third step is an FWD measurement. All this gathered data will be further calculated and used in a multi-parameter FEM simulation in the fourth step. All this data is concluded in a report and is concluded with a Kistler's recommendation for the accuracy and the possible layout. If you want to know more about the process with some illustrations, there is a video available on YouTube on the official Kistler channel. So let's go a bit more into detail of all those steps. The road geometry parameters are analyzed remotely by our experts. The results are summarized and suggestions for more detailed analysis are documented. The second step is to check the magnitude of road surface influence when the IRI is measured. This service doesn't need a road closure. The third step is to measure the structural road quality using an FWD device. That's a falling weight deflectometer. It's the most widely used non-destructive method in any part of the world to measure structural road properties. This service needs a road closure. With the measured data of this, Kistler is able to calculate the elastic modulus of each road layer, which is the most decisive parameter when it comes to assessment of structural stiffness for the WIM site. So the next step is the multi-parameter FEM simulation. All the measurement data is fed into a FEM simulation developed just for this purpose by Kistler experts. The highly sophisticated algorithms assess the data, simulate stiffness and behavior of the road, and pinpoint the best section to install the sensors. On request, a simulation for the optimal sensor layout can be added to the offering. All these steps are now finalized in a report with a Kistler recommendation. It's an assessment of road conditions, WIM site classification results, recommendation of WIM site installation location, recommendation of the layout, recommendation for the data logger calibration, and a statement about the achievable performance. Since there are other factors as well, remember the vehicle dynamics, the environment, and so on, there is no guarantee for this. So let's conclude this with a success story of an SRA in Switzerland. The initial situation was to replace an existing WIM site for pre-selection, and it is planned to add a new layout of Linea's digital sensors close to the existing layout. Using the site for direct enforcement must be available as an option in the future, where the static weighing is replaced by the automated dynamic measurement with Kistler sensors. The new system has to be highly accurate in terms of gross vehicle weight, detection rate, and confidence level. This road has not been repaved for above 10 years and is not intended to be renewed soon. For this reason, Kistler offered to the customer an SRA as a service together with the WIM sensor. At first, the FWD measurements were conducted where the structural road properties of the road are tested. Then the IRI was done, and with those results, our engineer could run the simulations and calculations. What's the conclusion? The area around today's installed layout is suffering from increased rotting. Therefore, the initial intended position of the Linea sensors is not meeting the Kistler road requirements for direct enforcement. The best location to install the sensors was found to be at a distance of 33 meters from the old layout away. So despite that this road was considered quite a good road, this service provided a better position for higher accuracy and lifetime levels. Further, we were able to recommend the optimal sensor layout. I would like to finalize this presentation now. Thank you for your attention. Visit us on our website and don't forget to download our WIM service app for your mobile phone. It helps you to record the installation process of our WIM sensor Lineas.